Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. Alright, well, everything looking good. Now let me share this guy. Okay, so I'm just going to get the screen down for a second. Gonna share the link. Link. Okay. Alrighty, well, Codotaku, stream on. Going to share on the Zig server. Why not? Where's the Zig server? There you go. All right. Cool. Alrighty, well, there we go. Let me get the chat on. Pop out the chat. And yeah. Alright, cool. Oh yeah, an AROC based translate-c for the Zig compiler. So I had a comment, I think, on the first live stream about this kind of thing. Like someone have asked, I think, on if can the translate-c of Zig can fail or not. And of course he said it can fail, but it would be better when an AROC kind of based translate-c compiler is being made, I guess. Something like that. So yeah. Alright, so well, just waiting a bit for if anyone is interested can join in. And then we'll start our adventure for today. I honestly don't have any plans for today. But we'll see. Just let the water flow. Or should I say the coffee flow. So, yeah. 3 minutes in. Guess we're gonna wait until around 5 or 10 minutes. Then we'll start. Okay. Let's go. Soon I'm going to get a second screen so I can put the chat in there and the stream stuff in there, which would be nice. But yeah. Okay. All right, 5 minutes in. I guess I'm gonna start. Let's go. All right, so Where should we start? Okay, so first of all, I actually have renamed the readme to readme.md, and right now it's actually formatted, as you can see right now. I didn't know that I had to actually add the extension .md so it can actually be interpreted correctly. So there you go, fixed. Now it's much better looking. Other than that, I think let's just make this like this. Okay, cool. Let's go. Alrighty, amazing. So one thing that I'd like to change about just a little minor thing that would be nice is we have some constants here. Now instead of having them as constants, we may be able to do something more interesting, which is to basically have fn context and to just basically use generics. So you would have something like max stack physical devices, and that would be, I guess, maybe comp time int, I guess, maybe, or actually usize. Okay. But of course these guys should be comp time, compile time, and then we could basically return this guy. Okay, cool. Expected return type, this will return a new type, and there's no need for this anymore because right now we're gonna go down and we can basically say context, and the max stack physical device, you could choose it here. Then the max stack key families, let's go with 8 for now. And there you go, much nicer. So it's configurable. Okay, cool. Although that's in compile time. Other than that, I think maybe I'd like to actually split these guys into their own files, maybe. It's kind of annoying, but honestly for now it's fine. Anyways, so let's go next, I think, with the comp time, the compute pipeline stuff. All right, let's try to go ahead and do it. So we had this stuff, and honestly I kind of tried to over engineer it last time. So because I've done a big mistake, I was trying to kind of like abstract it before even getting some functional code, which of course you should never do. So that's what I'm going to try right now, honestly. So let's just grab this guy, and I think let's just put it into the main function until later on, and then we could try to abstract that stuff. Okay, cool. That's the init, and of course the dinit, and the other stuff is just, you know, let's remove it for now. All right, cool. So you would say defer self device destroy pipeline. Okay, no self anymore, so let's see what we got. So first of all, we're creating a shader stage. See, okay, cool. Flags, stage compute bit, because we have a compute shader. Then we have the shader module.handle, which is correct. P name equal main, specialization info, no specialization info there. Const infos is equal allocator.alloc, vacate compute pipeline create info. There's no need for all this craziness. This is just over engineering for now. And yeah, device. Where is the device? Well, it's inside the context. So you would say context.device.create compute pipelines. And same thing, I guess, here for now. Okay, infos.len. Now instead of infos.len for now, let's see. So I'm going to basically say, I guess, const shader stages maybe. And I would say this should be basically some kind of an array, I guess. And I would say this. Cool. For now we're gonna have one shader stage right there, I guess. And yeah, pretty cool. So flags, bname main, return switch. So now we're gonna have, I think, so creates compute pipeline. What it does take, it's pipelines. So let's see what this guy takes. Create compute pipelines. This is it. It takes a vacate compute pipeline create info. Vacate compute pipeline create info. Okay. Const info, I think, is equal to c dot vacate pipeline create info. Why it doesn't pop up here? Why? Vacate compute pipeline create info. Okay, where is it now? There you go. Nice. And we're just going to basically save this. And you could basically go ahead, infos, and here allocation callbacks for now, just gonna be null. And the pipelines here, you should actually go ahead and I think maybe allocate, maybe. Let's see. Well, const pipelines is equal to c.vacate pipeline, and maybe we could say infos.len. Maybe, can we do that? I wonder. Okay. No, so let's just get the device here. So const device is equal to, well, context.device. And you would basically say device.handle device. Honestly, let's grab the allocation callbacks anyways, so it's easier to refactor later on. So how you would do it? Yeah, so optional pointer to c dot allocation callbacks, and for now it should be equal to null. And now I do not have to hard code it. There you go. And here device dot destroy pipeline. And reachable code, well, just do this. And no need for this for now. And here device.handle. And here you're basically going to get a pipeline. Well, oh, I see. So here for each pipeline you would actually go ahead and destroy them. So for pipelines, pipeline. Let's go. Pass in the allocation callbacks, device.handle. Nice. And yeah. So I think, well, where we're using the shader stuff. So here, we should try to say, well, vk compute pipeline create info. What that needs, it needs this stuff. So let's copy it over, put it here, put that stuff there. Just going to comment it for now, and let's see what we need. So first of all, the s type, as always, is equal to dot, well, c.vk structure type compute pipeline create info dot pnext. Well, pnext is equal to null, and dot flags equals 0. Dot stage is equal to shader stages, I believe. And I guess you would basically AK pipeline shader stage create info. Well, I guess maybe you would just basically say, in this case it would be 0, basically the first one, I guess. And other than that, you'd say dot layout is equal to our, well, pipeline layout. Next up, it would be base pipeline handle and stuff. And for that, we're just gonna say null, I guess, in this case. And oh, okay. And base pipeline index dot base pipeline index for now is equal to 0. Well, that's a lot of nulls and zeros, but okay. And yeah, let's see if this would work by any chance. Does not support array initialization syntax. What are we talking about? I think this one. I guess you would say this, and maybe the same thing with this guy. And what's the problem with this guy? Pnext. So we need pnext. Okay. Pnext is equal to 0. Null for now. Okay. Zig build run. Expected. Found main pipeline. Oh yeah. This needs the handle. Expected one array elements found 0. Well, can I just say, well, I think it's a matter of saying this and then saying undefined here maybe. Cast discards const qualifier. Well, var here. Switch must handle all possibilities, of course, and reachable. And value of type struct. Yeah, I see. So for now, I'm just going to say this. Cast discards const qualifier. Pipeline. I think it needs to be a reference like that. And consider using, okay, so I need to do this, I guess. No. I found const c.struct vk pipeline 2. Weird. Non-pointer type. Okay, I think it's a matter of saying 0 to pipelines.len, let's say. And then you're going to get the index. And basically after that, I could say pipelines index. Maybe I do need an address operator there, but let's see what's gonna happen here. It seems to be fine. Do I really need this guy? No, I don't. Okay, fine. And there you go. Seems all good, I guess. And let me run the vk config thing. And let's have the API dump. Let's go back, run it. Let's see the dump. And vk creates compute pipelines. We got vk success. Cool. Cool. Nice. So we have successfully made a compute pipeline. Okay, cool. Now, create compute pipelines. So how would you actually abstract this out? Because the thing is, as you can notice here, is that pipelines should be basically made in a batch, in one go, instead of one by one. I mean, you could create them by one, but the API is designed so to suggest that it is much more performant to basically create a batch of them at once. And also you would basically need to call into the API only once. So that's great. So for that, I think let's go back to our abstraction now. And we would have pub struct, well, actually const, right? So you'd have const compute pipeline, I guess. And well, honestly, you would just have pipeline, okay? Because that's what it is at the end of the day, because it would just have a device and allocation callbacks as always, of course, self right there. And of course is equal to struct and that thing. Cool. Under the stream still fine. Yeah, seems all good. So we have allocation callbacks and then of course the handle afterwards. So for the handle is going to be c dot pipeline, vk pipeline. Okay, cool. And it won't have an init function, I think, for now at least. I think it will only have a dinit for now. And the dinit would of course give a void, and it would take self, and it would say, well, self.device. Well, actually we would have an init function, but it would not be like the regular init functions, I think. So we'll see. Anyway, so self.device, and we would say destroy pipeline. Okay, cool. And then I would say self.device. Afterwards you give, I think, the handle, and then I believe you give the allocation callbacks. And yeah, that's pretty much it for the init. And now I guess maybe let's go with init. Now init would be very simple. I'm not sure if init could be, I don't think it would error this time, so it would just give you a pipeline object, so or self. Well, you can't error. So fn init, and you would basically pass it the device, and it would pass it the handle directly. It wouldn't create it itself, you know, because we're coming to that in a second. And it would return, and of course you also need the allocation callbacks though, which is going to be c.vk allocation callbacks. Right, so I'm trying not to compromise the flexibility of the Vulkan API, otherwise we're gonna make a lot of assumptions that could be wrong while learning. So anyway, and also it would be very hard to do some radical changes to how things works, how abstractions works, you know, if you like, the more your project gets bigger and bigger. But anyway, so we're gonna say device is equal device as always, and of course the allocation callbacks, well, the allocation callbacks is equal to allocation callbacks. Okay, dot. Cool. Other than that, you would have the handle, I believe, is equal to basically handle. Okay. And that's pretty much it, I think. That's basically the pipeline struct. Cool. Next up, we would have like compute pipelines kind of factory in some sense. So const compute pipeline. Pipelines maybe equal to struct, or compute pipeline factory or something. I honestly don't know what to call this one. Or batch, compute pipeline batch, maybe. But we'll see. Anyway, doesn't matter that much. So, const self this, I honestly don't know if we need all that stuff. Although, of course, well, let's see. Let's see. So, how would this work? So I wonder if this should be basically just being used as kind of like a static class, and it would basically just create that stuff and you could just de-init stuff yourself. Otherwise, you could also be kind of like a container of pipelines. So you could say compute pipelines, I guess. Okay, let's just do the regular way and we'll see later on how that would work. Okay. But this time you'll have handles in some sense, and it would be a slice, I believe, of pipeline, type pipeline. Okay, and maybe you would have a init function and it would give you back, well, compute pipelines kind of. And of course this one could error, of course. So fn dinit, and it would take only self, and it would return void. And the init could basically take ownership and basically kind of like destroy everything inside of it, like all the pipelines that they have created. So you would go through every handle in handles, and actually handles like this and handle here. Use if and declare, of course, self.handles though. And here you would of course say this guy, I think. Device, use of indicator identifier device. Well, honestly, no, we do not need this stuff. We just need to say handle dot, well, dinit, as basic as that, because we already have done it here, so that's nice. So for self.handles, handle dot dinit, as basic as that. And we can in fact even make it one liner right there, cool. And in the init function, now this is where things gonna be interesting. Now what I'm wondering about right now is, for example, can you have like multiple infos that uses the same shader stage? Does that make any sense? Okay, let's see. Pipeline layout dot handle. So I think the right question to ask here, could you have the same, could you use the same shader but with a different, let's say, layout, or a different base pipeline handle or base pipeline index? I do not think I'm going to be using this, but so different pipeline layout. Well, pname. Also, you could indeed use, well, I think I'm going to make assumptions here for now, at least, just to keep things simple, I guess. At least for now, and for our application. Okay, let me check VK pipeline layout, just to have a better idea of what I'm working with here. Opaque handle to a pipeline layout object. Okay. Access to descriptor sets from a pipeline is accomplished through a pipeline layout. There's not a lot of information right there. What about this one? Let's see what ChatGPT would say about this. Let's see. Although, but anyways, so okay. All right. Can let's see. Can a shader use multiple, I guess, pipeline layouts? Vulkan or something like that. right, anyways, well. Okay, let's just copy this stuff anyways. Anyway. For pipeline switch, create compute pipeline, etc. So all of this stuff should go there. Okay, let's see what we can do here. Pipelines.len. There's no need for this anymore, we already have done that. Okay, well. First, you need shader modules. And this is basically how much compute pipelines you're going to create. Shader module.handle. For now, we just have one pipeline layout anyways. But of course, we do need the device first of all and the allocation callbacks. Okay, let's grab those. So device and the allocation callbacks. Okay, it would be this guy. And other than that, you need stage compute bit. Honestly, let's just, I guess, say shader stages anyway. And you would say, for now, you would say this. Of course, we don't need this. We need to get a slice basically. And so the shader stages for now would live in the main function. I'll see how we can deal with that later. And for now, we're just going to assume that we're going to be using one pipeline layout for all of them. Although that's not necessarily true, honestly. Well, actually that is. Anyway, we already have got those right now, I think. Or no? No. pnext flags stage. Or we could basically take a slice again. And that slice would be shader stage as well. It would be pipeline layouts, I think. It would basically define the pipeline layout to use for each and every compute. So vacate pipeline layout. Yeah, that actually makes sense. If you have multiple compute shaders, you don't necessarily have the same pipeline layouts because you don't. Yeah, anyway. So now you would probably say pipeline layouts. And I guess you would have some sort of index here. Okay. Hello, Omar Abrage. Hopefully I spelled your name right. Welcome to the stream. Okay. So shader stages, and I believe we would also say here .I anyway. And pipeline layouts. Cool. Okay. Now, okay, so how you would actually create this. So let's actually remove this from here. Let's just grab it out, and the infos the amount of infos would basically be the same as the amount of, well, let's, for example, shader stages, same amount of pipeline stages. Or honestly, I guess we could basically say const compute pipeline and info, I guess, or create info. Equal to struct, maybe. And you could basically abstract all that stuff. For example, you would need the shader stage c.vk pipeline shader stage create info. You would need the pipeline layout c.vk pipeline layout. And you no longer need these two guys. And so I also did this so because here this is kind of dangerous because you're assuming that the caller will take responsibility to make sure that the shader stages length is equal to pipeline layouts. So instead of doing that, we could basically bundle that stuff into its own struct. What are you making? Who knows? Only God knows. Just learning Vulkan, really, and kind of trying to make some kind of compute application. Not sure really on what you're going to use Vulkan for exactly. I do have some ideas, but not exactly yet. What's the output of all of this? Okay, well. There's only input for now, which is coffee, so no output for now. Okay, cool. So compute pipeline create info, and it would be a slice. And here, of course, infos is that guy. Create infos, or honestly, I'll just do that. Create info const. Now you would basically go ahead and construct that stuff. That's kind of crazy. Use Vim when okay, pipeline infos. Honestly, why I'm even bothering on abstracting this, I don't know. That's weird. Well, honestly, that's super true. Why I'm even trying to do this currently. Anyway, never mind. So I'm just gonna put this guy here, I guess. And here you would have, what is it called? Infos is equal to that stuff. But of course this would be c.vk compute pipeline create info, and it would be an array. So you'd have something like this. And there you go. Now shader stages, I don't know yet. I'm just gonna say for now shader, first shader stage there, first pipeline layout, I guess, or well, for now I only have one layout, so who cares. So there you go, and use local constants And then I could basically say compute, compute pipelines is equal to, well, compute pipelines.init would give it the device, and you would give it the infos, and would give it allocation callbacks, which I'm just going to go with null for now. And device, well, of course, try that out. And here we have the device. What we could do for that, where is it? Oh yeah, context.device. There you go. Cool. And now we're just gonna say defer compute pipelines.dinit. Let's go. Okay. I honestly don't know why I was trying to over-engineer it again. So yeah. Pipeline infos, no need for this stuff, crazy stuff anymore. You just have var pipelines and which would equal to undefined. Okay, cool. And you basically say context dot, well, device in this case, dot create compute pipelines device dot handle, comma null, infos dot len, infos use of undeclared identifier. Oh well. C dot vk compute pipeline creates info. Let's go. As simple as that. And you basically do that. Cool. And of course you return this. Well, actually, do you really return that stuff? Hold on a second. We'll see, because I still do need to wrap that stuff in its own pipeline object. So create compute pipelines. I guess it's fine. So let's just return this stuff. And if there's an error, well, you know what happens then. And other than that, if it's success, then we can do our stuff. So of course allocation callbacks and stuff like that. Other than that, you would say dot handles is equal to, well, here should be pipeline. Okay. Well, for this one, let's see. I guess we could basically make a block there. Well, not a Minecraft block. So I want to see Rust. No Rust for now. Return. Let's see. Well, what's happening wrong here? Of course, this guy. Well. Let's just do this. And then we're basically going to... Can we just say this? I wonder. Array literal requires address of operator to slice type. Okay, so we have to do this. So expected type C struct found. Well, what are you talking about? I guess we could say this. Is it like that? Expected type found. I mean, I think I don't need the address there now. Expected type found. Vk compute pipeline create info. found const make a compute pipeline create info. Maybe it's a matter of const. So here maybe I should say const like this. Yeah, I guess. Enable to evaluate comp time. Well, that's right, unless if I make this comp time. But I wonder if I really want to do that. I don't think so. But let's just try it for now. Will run. Oh, I see. So we cannot do this unless if we pass the array, all of the array. Okay, fine. So I think we gotta basically allocate memory for this. Right. Honestly, do we really need this stuff? Honestly, let's simplify this for now. Anyway, who cares? C.vk pipeline. There you go. And right now, it doesn't matter. We could just say this and this. And then here we would say this. And here, basically say dot handles is equal to, well, pipelines. And let's see, device type. What is null there? Oh, it's that pipeline cache, the cache pipeline or whatever is it called. Anyway, so that's how it goes. So we don't need this stuff anymore, but of course I should copy this over, self this that stuff, okay. And now I could basically say, instead of handle.d in it, we have to say error expected found. So self.device.destroy pipeline, okay. No need for all this stuff. I mean, if we need it later on, we could just basically create that abstraction again. But right now, who cares? Okay. And used capture, of course. Well, where is the handle? There you go. So it should be like this, and there you go. For now, this is it, pretty much. Cool. I think here is the pipeline cache, right? Let's see the function. Well, Linux destroys that. It's Manjaro Linux, so Arch Linux, by the way. It creates compute pipelines. Okay, pipeline cache is either vk null handle, indicating that pipeline caching is disabled, or the handle of a valid pipeline cache object, in which case the use of that cache is enabled of the duration of the command. Pipeline caches are very useful for optimization. There is also other stuff like derived pipeline, etc. But from what I've read about it, pipeline, like, you would get the most performance out of pipeline caches, especially I think in mobile, maybe, not really sure, but yeah, anyway. So, and basically you could kind of like somehow save that pipeline cache even to a file, and then you could load it, something like this, if I remember well. I never really done it. I mean, we could try it right now, maybe. Pipeline cache. I mean, let's have a look. I never really tried that one. Vulkan specification. And if you want to understand the whole specification or the whole Vulkan API, you gotta read through. Oh man, that's a lot of stuff right there. It's huge. Okay. Pipeline cache, there you go. So pipeline cache objects allow the results of pipeline construction to be reused between pipelines and between runs of an application. Reuse between pipelines is achieved by passing the same pipeline cache objects when creating multiple related pipelines. Reuse across runs of an application is achieved by retrieving pipeline cache contents in one run of an application, saving the contents, and using them to pre-initialize a pipeline cache on a subsequent run. The contents of the pipeline cache objects are managed by the implementation. Applications can manage the host memory consumed by pipeline cache objects and control the amount of data retrieved from a pipeline cache objects. Okay, cool. So this is how you create them. You basically pass a create info, so simple, allocator and pipeline cache, okay? So once created, pipeline cache can be passed to the vk create graphics pipelines. Ooh, so what? Vk create graphics pipelines? Oh, and vk create compute pipelines, okay. Oh, never mind. Okay, I see. If the pipeline cache passed into these commands is not vk null handled, implementation will query it for possible reuse opportunities and update it with new content. The use of the pipeline cache objects in these commands is internally synchronized, and the same pipeline cache object can be used multiple threads simultaneously. To the cache. Okay, so this is the vk pipeline cache create info struct. You basically give it flags, which would probably be 0, next, pnext, null, initial data size, and initial data. So it's the number of bytes in p initial data. If initial data size is 0, the pipeline cache will initially be empty. Is a pointer to previously retrieved pipeline cache data. If the pipeline cache data is compatible, will be initially empty. But hold on a sec. Oh, never mind, I see. So I was just thinking, like, if the application have like retrieved the cache from a file, from a saved file, but then the application happens to select another device, another GPU, then which means it would probably be another implementation. So what would happen then? But that's not really. Anyway, never mind. 0 is ignored. P initial data is ignored. Okay. Cool. But how do you actually save the data? Let's say I want to save that data into, I don't know, a file, and then load it when the application goes on again. How you do that? Do you just like allocate some sort of array of some sort, right? And you just pass it that, then you just save that array? Is that it? I mean, I think that's the case. Really? Yeah, I think that's the case. Yep, I think so. So I guess maybe let's try it. Let's try. Although I'm really not sure what initial data size I would pass to it. I think let's research. Let's see. Pipeline cache size Vulkan. Let's look into Stack Overflow. So creating a pipeline cache, and how you do this, okay. Oh, all right. So you actually call another function called vk get pipeline cache data, I guess. because that's just the initial data. Yeah, that's what I thought. Okay, and the maximum size of the data that can be retrieved. All right. I think I think I should basically pass in null at first. It's either null, okay. All right, gotcha. So basically the same way on how we actually use it. Okay, cool. Let's try this out, honestly. Let's try this out. Okay, so how you would do this? Const pipeline cache. So before compute pipelines, we have to make that. So const pipeline cache. And define c.pipeline cache. There you go. Now, of course, we need to add some more functions. There you go. So we would say, well, I'm just gonna copy these guys for a second. Well, not in the instance, the device. Where's the device? There you go. Okay, cool. Well, before the pipeline, I guess, fine. And then we would basically say create pipeline cache and destroy pipeline cache. Let's go. pfn vk destroy pipeline cache. Hey, are you going to make another video about Rust and Vulkan? I don't know, honestly. By the way, welcome to the stream, Raf. I don't know. I really enjoy programming in safe low level in Zig right now, currently. Really, it's Rust in safe low level stuff like graphics programming is just too painful. It's like, and it's also not so safe. You know, it's basically in safe than Zig, programming in Zig. So honestly, I think Zig language, at least for now, from my own experience, I think Zig is the best language to deal with such low level and safe code. Although for Rust, I would really recommend that for high, well, not high level, but basically low level, but still safe code. Okay. So for example, using some kind of library or basically just the standard library of Rust, etc., etc. But really, graphics programming, especially Vulkan, is really low level, you know, and it's pretty unsafe. Like anytime pretty much you're kind of communicating directly with the driver, it's inherently unsafe. And even tools like Valgrind, for example, really struggles when you're calling into drivers. Thinks that there's memory leak when there's not. Stuff like that. Anyway, so hopefully that answers your question. But yeah, pfn vk destroy pipeline cache. Oh, cool. vk create pipeline cache, I believe here. Let's go. Cool. Nice, nice, nice. Now let's load those pointers. Well, but I don't know. I mean, I could probably create another Vulkan tutorial for us in the future. Who knows? Depends. But yeah, at least for now, I don't think so. But you never know. So. But surely there is some more tutorials coming in for Rust. I actually love Rust. But it's just too painful to work with when it comes to unsafe code. It just doesn't worth it for me currently, at least. So, yep. Create. And since currently, you know, like the thing is, my mood kind of like goes through Like from the moment I started programming, I always oscillate between low level and high level code. You know, it's like sometimes I have the mood to work with safe stuff, like high level stuff, you know, like starting with HTML, CSS, JavaScript, Python, you know, and stuff like that. And then and using fancy tools like game engines, you know, and stuff like that, you know. And sometimes I just like to go really very low level, very deep, like exploring operating system stuff, exploring graphics programming, etc. So, and honestly, it's a pretty interesting way of doing it because you get to taste both worlds at the same time. Well, not at the same time, but basically. So the thing is, when it comes to programming, there's some people that likes to learn from high level and then keeps on going to low level. Okay, so you start with something like HTML, and then you keep on going down, down, down until you find yourself programming in, let's say, C or assembly or whatever. Of course, when you're an expert. There is some people that starts low level, like in C, and then just keeps on going up the scale, which is actually hard at first, but then later on it becomes very simple, very easy. You know exactly what you're doing. And there's people like me who likes to kind of like go like this. So you learn a bit of high level, you learn a bit of low level, you go step, another step, etc., until you find yourself in the middle layer where you basically can program in both and make them work. At least that's what I think it is, but yeah. Okay, pretty cool stuff. So I don't know what I was doing here. Okay, so I copied that thing. Cool. And then here you have, let's see, creates compute pipelines. So pretty much even the things that you see in my channel is kind of like just sharing with you what I'm learning currently and what I'm passionate about currently. So it's not really, there's not really another motivation to it. So I mean, even my videos currently are like no ads, and I do not get any profit out of it whatsoever. So okay, cool. Now create compute pipelines, because I think I'm passionate about learning stuff, and I kind of try to make it even more productive by basically sharing it with other people, and also I get to learn more by sharing it with other people. And some people might you know, like correct me in some things, might add some more value into what I already know. But yeah, anyway, let's just go back into business. So vk create pipeline cache. And then we have destroy. So here, pipeline cache. Destroy pipeline cache. Yeah, doing things for pure motivation is so much more exciting to do and watch. Yeah, pretty much. Create pipeline cache. And I think Zig, Vulkan, and such new technologies are very, very interesting. Sticking to old ways of doing it is not always so good. Of course, it's good to explore those things just to know how things evolved. You know, like for example, you start with OpenGL and you go to Vulkan and you see how everything evolved and how the technology evolved. But yeah, anyway. Especially when it comes to things like operating systems, you know. Anyway, Create pipeline cache, destroy pipeline cache, vacate, destroy pipeline cache. Okay. Hopefully I'm spelling these stuff right. That's why you shouldn't work with strings if possible. Work with enums. Yep. That's why I may actually later on create another file where I put string stuff. So when I want to see if there is any problem with strings or whatever, naming stuff, I could look into that. But in the actual code where crazy stuff is happening, I basically would have just a struct where I could say dot, you know, and I would have like compiler errors if there is a typo there. But basically, if I think there is some typo, I could just look up that that whole struct of strings, and I could see there, look for typos there, because I know exactly that there is surely no typos in my actual code where stuff is happening. But yeah, for now it's fine. Vacate, destroy pipeline cache. Vacate, create. Bro, I think I'm doing something wrong here. Create pipeline cache. Destroy pipeline cache. Okay. Create pipeline cache. Destroy pipeline cache. Yep. I think that's pretty much it, I believe. Now we could go back. And by the way, Vulkan, it's pretty much the same thing in any language. You know, it's like you could look up videos on Vulkan about like using the C language, using Zig, using Rust, whatever. It's the same thing. It's just a matter of taste, I guess, and maybe a bit of performance and flexibility when it comes to language. And so far, I'm enjoying Zig and what it brings to the table when it comes to unsafe low-level code, and also it's so flexibility and simplicity. It's pretty interesting. So anyway, where I'm creating the pipeline cache stuff now. Well. Okay, I think device, right now we have to say context.device.create pipeline cache. And here we gotta figure out what we need to give it. Probably device.handle, as always. And then you probably would have the create info thing, and you would have, I think, probably an address to info, but we'll see later on anyway. And then it would probably have allocation callbacks. And honestly, pipeline cache is so simple, so we can abstract it right away. So const pipeline cache is equal to that, const self is equal to this. Let's go. And then the same kind of header for Vulkan objects. You get the device and yeah, and the handle. What's the problem with this? Yeah, struct here, forgot about that. And here you basically would have the handle, which is going to be c.vacate. Well, not handle, but pipeline cache. Okay, cool. Let's go fn init now. And this would give you, of course, self, and I believe it could error, right? Then fnd init, which would give void, and it would take self. Okay, cool. Now fn init. You would surely get the device and the vacate allocation callbacks, as always. And you would get the info, which would be c.vacate pipeline. What? Create info. There you go. Okay, nice. So now we would basically do that stuff there. Let's grab these two guys and let's take it here. Now info, and you would get the allocation callbacks, I believe. And the init is so simple. Self.device.destroy pipeline cache. Let's go. You would give it the self.device, I believe, and then self.handle, self.device.handle, and then self.handle, I guess, and then self.allocation callbacks. Okay, cool. Cool. Local constant shadows declarations of pipeline cache. What? Oh, this should be like this. Cool. Now, oh, I forgot about something. Oh yeah, I think you would probably need reference there to pipeline cache, right? Let me make sure that's the real signature. Yeah, seems like. Yep. Okay, let's go back. Let's go back. All right. I think that's it for that one, maybe. Although we could actually look up into that vk pipeline cache and just basically create it here actually, because it's probably so simple. Alright, sure, let's try it out. I guess const info is equal to c.vk pipeline cache. Alright. It's an opaque. Oh, my bad. Pipeline cache info. And what you need there, well, c.vk pipeline cache create info. Okay. Now let's see what we need for this one. We need this stuff. Okay. The only thing that bothers me with Zig currently is basically the tooling around it. The fact that we do not have great auto-completion, for example. Other than that, it's pretty interesting. So, S-type, well, vk structure type. Pipeline, cache, create info, let's go. And then .pnext is equal to null. Flags 0. Initial data size oh, I think this is where you basically get the loaded stuff. So if you, alright, gotcha, okay. So for that, we would basically say, I guess, okay, cool. We would say data. And this would probably be a U8, I guess. Maybe. And then here we would say dot initial data size is equal to data.len, and then .p initial data, it would be equal to, well, reference to data, I guess, or actually since it's a slice, we'd go with data.ptr. And yeah, that's pretty much it for that one. So instead of passing in pipeline cache create info right now, for now at least, we just pass in the data, the loaded data, if you got it from a file. That's pretty much it. Otherwise, we could have another function other than init and dinit, which would basically take the data. And I'm not sure what to call that one. I guess we'll just call it get data. So self, and I guess this would give you a buffer maybe. I don't know. Anyway, let's just go with this one. And of course it could error, that's for sure, I guess. At least maybe. Yeah, wiki result, there you go. So yep, there you go. Okay. Okay, so we're going to use this wiki get pipeline cache data function. Well, we gotta load the address stuff. Now I need to fly to another continent to do that. Okay. Destroy pipeline cache, and after that we would have, well, this guy or whatever, copy it over, paste this into here, and of course get pipeline cache data. Now we would go to another continent once again, actually another country this time, and we would say .get pipeline cache data is equal to Lloyd, and kind of similar thing, but of course let's copy this guy, put it here. Yep, we need a comma there. And yeah, oh, I did something wrong here. Okay, hold on a second. It should be here. Okay, man, that's crazy. Should be careful. Okay, anyway. Now I could use that. Shader module, pipeline layout, let's go, and pipeline cache. Okay, here I would say self.device.create, well, get pipeline cache data, and what it takes the device pipeline cache. Yeah, which is the handle. Okay, I lagged there a bit. Okay, and here I believe the size, right? And null, since we want to get basically the, oh, this is kind of weird. I'm kind of used for Vulkan stuff, for the Vulkan API, to use uint32. But this time it's actually using size t. Interesting. So const size usize would equal to undefined, and self.device here, of course dot handle, and then you would basically allocate for it. So const allocation, or what, cache data, let's call it cache data, or just data, who cares, is equal to, well, here we gonna need the allocator. I can get an allocator here, dot allocator, and self dot allocator, well, actually not self dot allocator, allocator dot alloc. It would give it the type, which is in this case, well, I guess just U8 maybe. I mean, I need to figure that out. Hold on a second. But the amount of data in the pipeline cache in bytes, or what exactly? I think in bytes. Most bytes, p data size bytes will be written to p data. Okay, cool. So it's in bytes, I believe. So yeah, and size here in now. Do we have to try that one? Yeah. That's a silly question. Const data, and then we would basically say this again, so you don't get a UB like the last time. Size, well, now we gotta actually give it the pointer to that data. And yeah, and that would fill out that for us. And of course, this would give us a vacay result. So we gotta return switch on that result. There you go. And now if it's c.vacay success, then how much is the time right now? Yeah, it's still, how much time we've been streaming? 1 hour and a half. Okay, not bad. All right, so c.vacay success, and now we're basically going to return the data, I believe, right? Yeah, I think so. And otherwise, for now, I'm just gonna say unreachable. Of course, let's, yeah, okay, this is fine for now. Okay. Cool. What's next? I believe this should be fine. All right. Cool. So I guess right now let's create a new pipeline cache. And we're basically going to, of course, also load the data, etc. From a file and save it to a file to boost the compute pipeline or the pipeline's creation in general. So pipeline cache is equal to pipeline cache. I'd never actually seen a tutorial before Vulkan, at least not a beginner tutorial, creating a pipeline cache. Just like I've never seen a tutorial using allocation callbacks before. Like they always just default it to null anyway, who cares? So if they want that allocation callbacks later on, they have to actually go through and look for all those nulls and change them to a variable. Anyway, right, self.device. What, self? No. You know, just say context.device. Okay. Other than that, you would give it the data. What data? This should be optional. Oh, well, yeah, I guess. Or we could basically, no need to make it optional, we could just pass in an empty thing, I guess. Does that make sense? And then the allocation callbacks. No. Okay. Of course, we'll go into encapsulate later on this stuff other than the context. For now, it's fine. Okay, cool stuff. So, the pipeline cache in use local constant. Well, defer pipeline cache dot dinit, and of course try to make this work. And yeah, let's just see if this would work anyway. Okay, what's wrong here? Expected type found void. Oh yeah, that's void. How do you actually create an empty slice? Alright. That's interesting. How do you create an empty slice? Zig empty slice? maybe you do this, possibly. Found type of. What about this? Okay, where this is coming from. Expected type C, you int found type of enum literal. What? Oh, C dot vk structure type, I guess. Okay, what's going on here? I believe I should pass in an address there and cast discards qualifier. This should be var, of course. And let me just put it down near the call site. And value of type cint ignored here. That's interesting. I have to return switch. And if it's c.vk success, you're good to go. Return the pipeline cache. Well, actually not the pipeline cache, but basically return a struct else unreachable. Okay, cool. Now vacate success. All right, you would basically give the device is equal to device and allocation callbacks as always, and then of course dot handle is equal to pipeline cache. Let's go. That's it. Let's try again. Enable to evaluate comp time expression. Oh man. var pipelines. What I'm doing here. Oh yeah, I have to actually go ahead and basically allocate here. Interesting. Okay. So how would we do that? So we need an allocator, I believe. Okay. Allocator dot alloc. The type would be c.vk pipeline. The n would be infos.len, isn't it? Yep. And yeah, now we gotta pass in the pipeline too. The allocator too. Okay. Okay, cool. That's easy. Allocator, and there you go. But of course, I should deallocate the stuff that I got. So to do that, we of course have to store the allocator too. So how would you do that? Well, allocator std.mem.allocator. Cool. And then you would basically say the allocator is equal to allocator. And in the init, you would actually go ahead, after of course destroying all the pipelines, you would go ahead and say self.allocator.free and which memory you would give. Well, you would give self.handles. Expected U32 found U size. Easy. As the comp time is going to be 32 and info stolen. I see what's going on here. So I have to cast it. Int cast. Would that work? Well. So what's wrong here? I think maybe you have to say .ptr here in this case. So expected type. Oh, well, I gotta try this out. What's the problem again? Maybe I have to actually pass in this guy now. What? What error now we're getting from PTR here? Pipelines. Expected type found. I guess maybe I have to say .ptr here instead. That's weird. Well, expected type. Oh, that's simple. Handle. Let's go. And finally, git run. So let's see what happened there. So we were successful in creating pipeline cache. Amazing. And it seems like this is how you create an empty slice, I guess. Okay, cool. Great. Did succeed? Yep, it did succeed. Nice, nice, nice. Let's actually make sure to get the validation now. Let's try the validation layer now. Sigbuild run. Nice. Nothing crazy there. Cool stuff. Of course, I'd like to optimize this guy right here. Well, I think I'll do something similar to context, maybe. For now, it's fine, honestly. This is fine for now. So, other than that, I'd like to maybe right now create a file basically and cache and put in it the pipeline cache data basically. And how we would do that, well, good question. So let's see, pipeline cache file, I guess. Or we could honestly put that maybe in the, well, let's just do it here anyway. Let's just call it file for now. And how you would do this, well, std.fs maybe, and then maybe open. Okay, open file. Well, So I think I would get the CWD, which is the current working directory, and then I would create a file here, I guess. Or otherwise we could look up the temporary, the temporary folder in the system and create it there. But honestly, for now, it's fine. I would just go with the current directory, so it's easy to see and maybe even delete the thing, etc., etc. So let's just go with this for now. So create file. You would give it the subpath, which I guess I would call it pipeline cache for now. And yeah, I don't know if I'd like to give it any kind of extension. Can I maybe use the bin extension? Well, I guess. Anyway. And flags. I guess you could just say this, maybe. Const file. Now the fur, of course. Well, I guess I have to try this. Yep, sure. That's a bad question. Anyway, the fur file.close. Let's go. And after that, now actually I don't want to try this, because if it fails, I'd like to do something other than that. So, well, let's see what are the possible errors though. The open error. So there's all these errors that could happen. But honestly, I think what I'm gonna do right now is to simply, if there's any error, however it is, because in fact, even if there is a file and some of these problems happen, it still doesn't matter. We could still keep the application running, even if the cache file is not there or is corrupted. Whatever happens wrong with it, who cares? The application could still run, although maybe a bit of a warning, maybe in the console, just to tell you that something is there. So for debugging purposes, I guess. Okay, cool. So we would just say, so we would switch on this, okay? I think we would switch on that, but okay. Now no longer needing the try thing there. I guess I would just switch on file. Can I just do this maybe? I wonder. But anyway, so switch file, and then if we get, well, what you get in that case, switch what does it return in terms of success though? Switch. I think I shouldn't really use switch in this case. Yeah, you would say a file. Okay, cool. So here I may actually say maybe file or something. I don't know. Anyway, or I could basically say this, and this would give me the file, the opened file. Yeah. Yep. All right. Else, you would get an error, and depending on the error, you could do something. Okay. So now I would say the fur file.close here, and other than that, So depending on that, you would get some kind of data right there. So I think I could say something like this, data, and then maybe you could have var data is equal to this, maybe. And then, can I say file dot read? Well, what's wrong here? File dot read all, create file. Okay, let's check the file. Okay, and I may need to make sure that the kind is right, that it is indeed a file though. Maybe. Yeah, honestly, I should probably do that. Other than that, how do you read a file? Well, I could look for basically the documentation, the standard library. Well, not this one. Doesn't seem like I have it here, I guess. Doesn't look like so. Anyway, zig std docs. Let's go. And let's look for std.fs file. Okay, let's look for read. I guess read all is what I need. Yeah. Buffer U8 returns the number of bytes read. P read all buffer. Cool. But why it's called P read though? There's one called P read all and there's one called read all. Okay, so one have an offset seems like, so, and we don't need that actually. So let's just go with read all and you would give it a buffer. The number of bytes being read. What I've done there. It means the file reached the end. Reaching the end of a file is not an error condition. Okay. Read all. I need to give it a buffer. But the thing is, how would I know how much memory I need to allocate for that? Is there a length in the file, I guess? Or size, or maybe I have to use kind of the similar thing on like C, where you have to seek to the end and get the size. I don't think we need that in Zig though. But who knows? How do you get the file size? Well, I think I have to use seek from end and then basically get the length from that. Let me have a look. Zig read file. Let's look for an example though. I've never really done this, I guess. buffered reader. Oh yeah, so I have, I guess, to... Oh, right now I remember. Okay, so you actually use a reader, then you would have a fixed buffer, and then you could use the reader to read some bytes. Hello, you want to know the file size? I think it's get end pause. I think, yeah, so I was kind of approaching the problem wrong. So I just remembered right now, you need to actually use a buffered reader and basically have a fixed size of buffer, and then you would use the reader to take those chunk of bytes every time. Yeah, that makes sense. That makes sense. Okay. So let's do that, I think. Although I would like to just use read all and you're done with it, but yeah, seems like this is much better, I guess, maybe for performance. So anyway, you would say file. Oh, by the way, Travis is back. Okay, well, welcome to the stream, man. Right. I just noticed that you are Travis. Okay, cool. File. Read. Well. By the way, you said git end pause. Let me try that on. Oh my god, it's so infuriating, the fact that... Anyway. So git end pause, integrate with async IO to do. Pretty amazing description. Anyway, git end pause, git end pause. It would give you U64, yeah, which makes sense. Okay, cool. So let's try to do that then. Let's just try to say .read all, although, yeah, okay, fine. Read all. If you just want to read the whole file, allocate in a buffer, file.reader.read all alloc works too. If you just want to read the whole file, allocate in a buffer, file.reader. Yeah, that's exactly what I'd like to do. That's much better. So you say file.reader dot read all alloc. Let's go. Works too. I don't know why, honestly, they don't give any kind of autocomplete in this case, but who cares anyway. Let me have a look into that reader, read all alloc. So you basically get reader allocates enough memory to hold all the contents of the stream. Let me see the source, by the way. That would be cool. So it basically creates an array list. All right, read all array list. And it calls another function, and I have to look up that other function again. Anyway, never mind, it's fine. Returns error stream too long. Caller owns returned memory. Allocates enough memory to hold all the constant stream. Cool. So I should pass it an allocator and the max size. Max size? That's interesting. What do you mean by max size? Can I just say max size, well, the maximum possible? Okay, let's have a look into what's... I think it's this one, right? Yeah. Ensure total capacity. Oh man, ensure total capacity. What? Oh, math.minimum? I see. But then where it's using that again? It's not using it at all then, or what? Why this guy is not being highlighted? That's super weird. Anyway, max append size. Well, actually file read to end alloc would be a better option since it allocates the whole slice at once. Alright, let's look at that. Honestly, let's have a look into the reader itself anyway. Read to end alloc. Well, let's have a look into that. There is no read to end alloc, I guess. Oh, it's in the file. Yeah, okay, cool. So this takes also max bytes. But man, what's this max bytes is supposed to be? I guess I would just say max int if you're concerned about perf. Oh, that's nice. So read to end alloc. Okay, fine. File read to end alloc. Cool. Read to end alloc. Allocator. So here I would give it the allocator, I believe, and then the max bytes. I guess here I could just use maybe, well, I guess it's inside math maybe. You would give max int size. I honestly don't know what to put there, but yeah, anyway. And that could, of course, fail. And there you go. But honestly, I'm not going to go with try. I mean, if that's successful, great. If not, well, who cares? Because cache is really not something that is critical for the application to keep on going. So yeah. So if file.read to end alloc, else there's gonna be some error that we could maybe try to handle later on, but anyway. Okay, so if rent to alloc, and this would give us the actual bytes finally. So bytes. And here I could basically say data, I guess, is equal to bytes. That's the case? Right, I think so. But of course, on success, caller owns the return buffer if the file is larger. So I have to make sure to, well, I guess, well, I guess after this, or I cannot say defer here though, because, well, it would basically deallocate it directly because it's inside this scope. But I guess what I would do for now as a hack, I guess I would say if data.len, I guess, is greater than 0, then for now I guess we could basically make sure to defer data.allocator.free data. Expected block or assignment found defer. Right, well, I guess we cannot do that. Oh, well, I could just say defer if data greater than 0 allocator.free. Is that the case? Defer. So yeah. Other than this, for now, I think we could just, at least for now, we could just ignore all errors, I believe. Although, honestly, let's just print them though. cd.debug.print. Failed to read. And also one other thing that I'd like to make sure though, if file.kind right, well, file kind file, okay, but where is kind exactly? There you go. Okay, cool. Let's go back, and you basically have to say dot kind, I guess, like this. But what this actually returns, hold on a second. Returns the kind of file. Okay, cool. Dot file. So if it's not equal to file, well, that means, and oh, I kind of got a memory leak there at some point. Okay, first of all, do that. Otherwise, so if file.kind that, then we could basically, well, how would you actually go out of this guy? Well, honestly, for now, let's just say that, and basically do this. Failed to read file. And then maybe we could do this and then error dot, well, just pass in the error maybe. Failed to read cache, pipeline cache file. And of course, I'm going to do the same thing. Should be a file. All right, other than that, here you could just have a debug message and it failed, and here failed to open pipeline cache file because of the error. And yeah, we could simplify this later on. For now, I guess this is fine, maybe. Okay, the moment of truth. Need to find out if this works or not. No field or member named kind in fs file.file. Interesting. File.file. But what's that? Oh, the metadata. What the? Well, let me actually have a look here. File. And let's look here for kind. How would you actually get the? That's weird. Do I really have to get the metadata first? And then I would find the kind there. That's crazy. Okay. So how would you do it? Let's look for metadata then. So you would say dot metadata and it could error again. Oh man. All right. You have to do another guy. Oh my god. Well, honestly, for now, well, anyways, okay, if file.metadata, yeah, what I've just done there. Guess I would take this whole thing and do it here, basically, and now instead of this, I could say metadata. And hopefully the kind cannot fail there. If so, that's crazy. I don't think it would. Anyway, if metadata.kind is equal to .file and yeah, else std.debug.print failed to eat pipeline cache file metadata. Anyway, I'd probably make this into a function later on. Anyway, expected optional type. Yep, so here it should be error. It should be file. Well, what? Oh man, I changed the wrong thing. Man, that's crazy. That's so much. Anyway. Well. Honestly, why I have all this craziness? That's another level right there. I think I've over-engineered it again. Crazy, man. Well. Okay. Let's entangle this mess. Const file is equal to this stuff. Try, okay? That's the first thing. And defer file dot close. Okay. Other than that, we would say file try const metadata is equal to file dot metadata. Okay. Try that out. Who cares? Other than that, it would get the kind. So if metadata.kind is equal to .file, then well, you'd do something about it. Else you would, well, return an error. I don't know, let's say wrong file type, I guess. Or we could say incompatible file, or well, who cares? Anyway, if meta.kind is equal to file, then we could basically try to read that guy, and we would say data is equal to try file.read to end alloc. Isn't the kind guaranteed to be file if you're creating the file? My bad, what I'm doing here. I was actually wanting to open a file though. Yeah. Good catch. So data is equal to try. All right, cool. Now I don't need all of this mess. So yeah, makes more sense now. Yep. Okay, cool. Honestly, I don't know why I have this on. Okay. Well, let's just compile and we'll find out. Expected type const, type of that, found that. Well, interesting. Well. Well, I guess I would say that this could be a U8 slice. Why go crazy about this? U8. This could be a U8 slice, and at the start, no. I don't know why I made it that complicated. I thought we didn't had optionals for a second there, I guess. All right. Anyway. Now. You would basically say the reference, well, hold on, data or anyway, how you would do that. So basically if data, then oh, well, why not we're making it optional here actually? I mean, hold on a second. Where is that thing where you're using it? If we go with pipeline cache, right. So this should be optional really. And data.len. And then you would basically say if data, but oh yeah, data dot, well, I'd like to first of all check, man, well, weird. Can I say if data.len else, I guess 0? Does that make sense? If data, then data.ptr else 0. I don't know if that makes sense. Okay. Else null here. Alright. Now that makes sense. Now if data, then allocator.free. Might be easier to not use option slice. You could just check if since len equals 0. Now that was my initial thought, but man, it made everything so much harder. Oh, okay, well, let's go back then. But I need to figure something out here. Now the problem that we have here is how do you actually create an empty slice? The only way I've seen Well, can I just say this, I guess? Oh man, my bad. I think I figured it out now. So basically I guess say this. Does that make sense? Let's see. Underscore. Expected type 0u8 found. No. How do you actually make an empty slice? Do you know how to make an empty slice? YouTube removed your comment. Yeah, I think so. Like this, I guess. Oh man. I guess let me look at the documentation then. YouTube keeps on it. You can actually send it to me in Discord. U0. Same way you init const slice emp.curlies. You mean this? Oh man. That was it? My god. Okay, anyway. Error file not found. Where is that? Okay, that makes sense because we have to check first. But in fact, I'm going to put this whole thing into its own thing, if that makes sense. So, well, for now, I'm just going to say fn read file. You would give it a path, I guess. Const u8. And then it would give okay, it would give a slice u8 and it could error. Okay, and then I would basically take this whole thing, put it here. I would say path here, although it actually calls it subpath, so let's go with that, I guess. Subpath. Okay, use of undeclared identifier data. And you would basically say, you just say return. Maybe I could even just say this, right? and you would need an allocator. cd.mem allocator. Okay. Read file contents, or we could say read file to string, kind of similar to Rust. Way of naming it, but anyway, read file to string. Cool. Or honestly, we don't know if it's a string, you know, just read file contents. Anyway. Okay, cool. Now I would use that read file contents. No need for this guy. Or actually, let's do that, and then basically read file contents. You would give this that, and then you would give the allocator. Okay. So defer. Well, otherwise, it would catch, and you would basically give it that guy. Now defer, if data.len is greater than 0, then allocator.freeData, I guess. And finally, it works, I guess. But of course, we have no idea if something happened there. Can I just say this maybe? I don't think. Yeah, I don't think. Well, anyway. For now, let's just do this for now, anyway. Or, well, okay, fine. Const pipeline cache. Now after that, you would basically, I guess, defer before you de-init it though. Expected. And also what you would do if you have multiple pipeline caches. Oh, well, that's an interesting question. But for now, anyway, I'm just going to assume we have one. Right, expected statement found. So defer, before we pipeline cache.dinit, we should basically open another file to save the contents. So how we would do it? Oh man. Oh. Let's keep it that simple, I guess. Pipeline cache.bin. I don't think you need an allocator, do you? I guess you do. Anyway, and other than that, you would probably need the data. And how would you get the data? Well, you just pass it. And what is the data in this case is pipeline cache.get data. And here you would also pass the allocator. Okay. Try not allowed inside the for expression. Amazing. Well, that doesn't matter. Okay. fn write file contents. you would give the subpath, which would be a slice of U8s or const U8, and you would get the data, which would be slice of U8s, and the allocator, which would be a cd.main.allocator. Let's go, and then you would give, well, there could be an error there, okay. Other than that, you would just say void. All right, here I would say I would open a file. So const file try cd.fs.cwd dot I guess you would create a file, then you would pass in the subpath. Other than that, nothing there, and you would I guess write all. You would give it the data, and this could fail, so we could say try, and then hopefully we could just say defer file.close, and hopefully that's it. And it doesn't seem we need any allocator, I guess. Weird. Okay, fine, nice. Right, amazing. Okay, I think that's it, although get data could fail, I guess. Try. Oh yeah, try not allowed. Well, I can basically say if that, then well, write file contents. Okay. Let's just do it here. Oh, I see why. All right, I guess that's how it should go. I cannot believe I wasted all that time on pipeline cache. Oh man, that's another level. Zig build run, and it doesn't even work. Expected type bool. Of course, well, else you would do something. Yo, what's going on here? I forgot about this one, and this one should be like this, I guess, and should have else. There could be an error. And there you go. Size, where that's happening. Var size. Value of type cint ignored. Cint ignored. Oh. You have to switch on this one too. And we have to try this one. And if it's vacay success, you're fine. Else unreachable. Well, that stupid problem again. All right. Yeah, it is indeed. I don't remember how I handled it the last time. I said try switch, and it worked. But why didn't it work here? That's crazy, man. Why did it work there and not here? That's another level. Crazy. We do need to try. That could fail. Just like that one. But I guess let me add this one and maybe that would work. What? Oh, what the? So I leaked some memory address, seems like. Get data. Yep, I did. So, well, allocator.free, I guess, bytes. Well, finally. That's a lot of allocations right there, though. And yeah, we got a pipeline cache. How big is that pipeline cache, by the way? $36 bytes? Is that really true? What? Is that really 36 bytes? Well, it seems like. Alright. I don't know. We're ignoring a lot of errors, so that's would be another level. Okay, so I guess I'm just going to take a little break and then I'll be back. Right, back. Well, there's a lot of spaghetti code right here. Well. Let me try to run it again. Okay. So next step would be to basically create, I think, a command buffer. To get the queue of the device, and there is still a lot of crazy stuff. But I think maybe it's fine for now. I think that should be it for now, I guess. I should have not honestly wasted time on the pipeline cache. Oh man. Okay. So if there's any questions, let me know. How much we've been streaming for? 2 hours, 38 minutes. Read file contents. Read file contents. I should probably just have an fn save and fn load in pipeline cache and call it a day. Yeah, I guess. So the problem would be when you have like multiple pipeline caches, which I honestly don't know why you would need such a thing. Oh, I mean, well, I don't know. I mean, you may need that though. Like you may have maybe 2 pipeline caches for separate pipelines, I guess. Like if you have 4 pipelines, for example, or let's say you have like 2 groups of pipelines. Each group, the pipelines inside of it are very similar, you know. Then you may have, let's say, for example, a pipeline cache for one group and the pipeline cache for the other group. But maybe. Okay, well. I think I'm just gonna stop the stream for now until we complete later on. I guess maybe tomorrow. But that's it for now, and see you later. Before that though, let me just submit this. Commit. And of course, if anyone would like to contribute, you're welcome. And please enter the commit message. Well, the commit message would be third stream. Okay. Save. And there you go. Pipeline cache.bin. And that's it. Sync changes. And yeah, that's it. Everyone, goodbye.